Hi PhysCalc, welcome to another video in the Maverick video series. In this video we're going to be talking about the chain rule. Now I'm sure you all remember the chain rule from like the bane of your existence back in November, but the chain rule is actually one of the coolest and most important rules in derivatives, and it's going to be a really important thing for us to understand deeply before we get into the integration version of this next week. So let's be really sure that we are confident in the chain rule and that we can apply it as necessary. So the Khan Academy explanation video went through a sine function and did a really good job of kind of walking through the different pieces of this, doing some thought experiments. So what we're going to do here is do a different kind of example, and I'm going to walk you guys through what I'm doing, why I'm doing it, and why the chain rule is so darn cool. So first things first, let's figure out what we want to take the derivative of. So we're going to take the derivative of the square root of x cubed plus 2x. So at first glance, we're saying, oh, this doesn't look too bad. An x cubed, I can do that. A 2x, I can do that. But we have this really gnarly square root to deal with. And in fact, we can think of this as d over dx of x cubed plus 2x to the 1/2 power. Because remember, that's what our square root means, is we're doing this to the 1/2 power. Which means we have one function, x cubed plus 2x, that we're doing a thing to. We're doing the 1/2 power of that entire function. But we've also got these teeny tiny functions in here that also have associated derivatives. So it's like we have this x cubed plus 2x that we're taking to the 1/2 power. So we've got our classic chain rule f of g situation. We have one function embedded in another, an x cubed plus 2x embedded in a 1/2 power. So the first and most important thing to know about the chain rule is that it's very front-loaded. It's very important to make sure that you do your work up front so that you can solve this more easily when we get to the actual derivative. So we're going to do some work right now to get this into a form I can solve. And the first thing I want to do is put this in terms of a y and a u. Now, the u is the inner function. The y is the outer function. So the things I've kind of put in purple here, that's my inner. And the 1/2 in blue here, that's my outer. Which means my inner function, my purple stuff, my u, is x cubed plus 2x. And my y is that purple stuff, that u, to the 1/2. So that's kind of the first thing I need to figure out, is can I put this function in terms of a y, which is in terms of a u, and in terms of a u, which is in terms of an x. And it turns out that in this case I can, so my chain rule does apply. And what the chain rule says is that dy dx, the derivative of y with respect to x, is equal to the derivative of y with respect to u times the derivative of u with respect to x. Now remember, we've got our u's here, and we've got a y here. Now, the reason this works is you can think of if we were to sort of cross these guys out, what we'll be left with is in fact my dy over dx. So this does kind of work all out. And you can find more formal proofs in the resources I already posted in the homework if you're interested. But just at a glance, you can kind of see that that is what we're doing here. We're using our u as a middleman. We're using it as a way to solve this more easily with the u I have chosen. So now it's just a matter of applying my chain rule. So dy over dx is equal to d over du of y times d over dx of u. So let's find these pieces first. Let's find d over du of y, and let's find d over dx of u. So remember, y is this guy over here. So d over du, the derivative with respect to u of y, is going to be 1/2 u to the 1/2 minus 1 is minus 1/2. And the derivative of u with respect to x, looking at this guy up here, is also relatively straightforward. So using our power rule, we just find 3x plus 2. All right, so now all the pieces are laid out here. I have my du, dy. I have my dx, du. Now I just need to put them together. When I do that, I find that dy dx is equal to 1/2 u to the minus 1/2 times 3x plus 2. And you might be thinking, I've still got this weird u in here. But remember, we found what u is equal to, so we can just plug that in again. So 1/2, and then my u is x cubed plus 2x, the negative 1/2, times 3x plus 2. My last step is to just simplify this out. I'm just going to do some algebra with it. And when I do that, I'm just going to make sure that all of my negative exponents go to the bottom, all of my fractional exponents become roots again, and everything gets multiplied together. So I have my 3x plus 2 on the top, and on the bottom I have my 2x cubed plus 2x, and it's the square root of that. So this guy right down here is my final answer. And this is the derivative of my function, which again I found using the chain rule. And that's it for this video. Happy chain ruling!